What if I told you that particles can be in two places at once, that reality only seems to exist when we look at it, and that the universe itself may be stranger than science fiction? Welcome to the world of quantum mechanics, the science of the very small, and one of the most revolutionary ideas in all of physics. Quantum mechanics deals with the building blocks of reality, atoms, electrons, and photons of light. At this tiny scale, nature doesn't follow the ordinary rules of Newton's physics, the kind that governs planets and falling apples. Instead, it follows bizarre rules where particles can behave like both waves and solid matter at the same time. One of the most famous examples is the double-slit experiment. When we fire electrons or photons through two slits, they don't just go through one or the other. They create an interference pattern, like waves overlapping in water. But here's the strange part. The moment we actually measure which slit the particle goes through, the wave-like behavior disappears, and the particle chooses only one path. Reality itself seems to change depending on whether we're watching. From this experiment, we discover the three core rules of quantum mechanics. The first is superposition. Particles can exist in multiple states at once until we observe them. Imagine flipping a coin that is both heads and tails until you look. The second is entanglement. Two particles can become mysteriously linked, so that changing one instantly changes the other, even if they're light years apart. Einstein himself called this spooky action at a distance. And the third is the uncertainty principle. We can never know both the exact position and speed of a particle at the same time. Nature builds in a limit to knowledge. At first, all of this might sound like philosophy, but it isn't. It's real, and it underpins our modern world. Without quantum mechanics, there would be no smartphones, no computers, no lasers, no GPS, and no MRI scans. Transistors, the tiny switches that power every electronic device, only work because of quantum effects. Today, scientists are pushing this even further with quantum computing, machines that use superposition and entanglement to solve problems that no ordinary supercomputer could ever touch. And with quantum cryptography, we're beginning to develop communication systems that are, in theory, unbreakable. But perhaps the most profound impact of quantum mechanics isn't just technology. It's how it changes our view of reality itself. Before quantum physics, the universe was seen as a giant predictable machine, where everything followed strict, deterministic laws. But in the quantum world, the future isn't set in stone. Instead, it's a game of probabilities, where observation itself plays a role in shaping what happens. So what does this mean for us? It means that the universe is far stranger, more mysterious, and more open-ended than we ever imagined. We've learned that the rules we grew up with are just one layer of reality, and beneath them lies a quantum world that defies common sense but works with astonishing accuracy. Quantum mechanics has already changed everything we know, and it may only be the beginning of an even deeper story about the nature of reality.